Today we're going to show you guys how you can solve an equation or an inequality by graphing. We've been showing you guys how to do this algebraically, and while sometimes algebraically is totally easier, we figured we should also introduce graphing as a skill to solve. So in the first one, it says solve negative 3x plus 20 equals 5. I could subtract 20 from both sides, divide by negative 3, and get my answer. Or if I'm doing this by graphing, then I would graph both sides as two different functions or two different equations that equal to y. And once I graph those, then I can look for the point of intersection where these two equations are equal. And if they're equal, that would mean that x would be my answer. So if I were to graph this, y equals negative 3x plus 20. The y-intercept would be 20, but I can't really see it. So I'm just going to start substituting in numbers. If x is 1, I get 17. If x is 2, that's negative 6 plus 20, which is positive 14. If x is 3, that's 11. If x is 4, that is negative 12 plus 20, which is 8. 1, 2, 3, 4, 5, 6, 7, 8. If x is 5, that would be positive 5. 1, 2, 3, 4, 5. And then I could just follow the slope of negative 3. Now, in order to graph y equals 5, I know that it is a horizontal line at y that touches the y-axis at 5. 1, 2, 3, 4, 5. And this point of intersection right here, this is where the x and the y are equal to each other. But the original equation is asking me to solve for x. So my answer is not going to be the actual point of intersection because I'm not actually giving you a system of equations. The original was an equation with only x. So my answer would be only the x value. Tomorrow we're going to start talking about systems. And if I were to give you this system, then your answer would be the point. All right. So for example, 1b, we're going to do the same thing. Step 1, we're going to graph y equals absolute value of x minus 4. And then I'm going to graph y equals 1/2 x plus 1. So for the first one, I know that it's a v shape. It's an absolute value, so it's got to be a v shape. And it is being shifted to the right 4. And then from there, I know that it has a slope of 1 over 1. The other equation is 1/2 x plus 1, which I know that it has a y-intercept at 1, and it goes up 1 over 2, up 1 over 2, up 1 over 2. Okay. Now remember, the answer is technically the point of intersection, but I'm only going to pick the x value. While I only see one intersection, I know that this will eventually touch. So if I were to graph this forever and ever, I would see that the answer would be x equals 2 and positive 10. Okay. So even though I can't see it, it'll eventually intersect. And I can show you guys what that will look like. You can also use decimals to double check that x equals 2 and 10 are the two x values where these two are equal. Example 2a, now we're asking to solve, but we don't see it as being equal to 0. Instead, we're being greater than 0. We have greater than 0. So the very first thing I'm going to go ahead and do is I'm going to sketch y equals x squared minus 4, which is a parabola that is being shifted down 4 units. And then once I shift it down, I could just make a table on x squared. Once we do this, technically I'm supposed to graph one side and I'm supposed to graph the other. So if I were to really graph y equals 0, it would be the horizontal line. But what this says is that we want the left side, we want the parabola to be greater than 0. And what that means, it means that the parabola is going to be above y equals 0. Because again, greater than 0 means that you are positive. So another way I could have done this problem is I could have said, where is x squared minus 4 positive? Greater than 0 means positive. And to be positive means that you are above the x-axis. So my answer is not so much one x value or two x values like before. Instead, there's going to be an infinite number of x values that are going to have a y value greater than 0. So in this case, because I'm only asking for x, then I'm going to write out the intervals, 2 intervals. One goes from negative infinity to negative 2, and the other one goes from 2 to infinity. Again, we just graphed x squared minus 4, and we said, where is it positive? Where is it above the x-axis? If this said greater than 1, then you would shift this line above 1, and then it would be asking you, where is it above the 1? Or you could subtract the 1 over and then still solve for greater than 0 to figure out where it's positive. So let me write that down. So I'm going to say, what if I had x squared minus, let's say, 3 is greater than 1. Okay? So in this case, I would graph 1, 2, 3. This is x squared minus 3. And then this would be the line y equals 1. And my answer would be where it is above. Where is the parabola above the line y equals 1? And so then again, it would be from negative infinity to negative 2 and from 2 to infinity. Or another way would be to subtract the 1 over and make it look like what we did and then see where it is going to be greater than 0. So again, this is just a what if statement, okay? All right, example 2b. A motorcycle is 40 miles ahead of a car. So that seems to be some sort of distance. The motorcycle travels at an average rate of 40 miles per hour. This is a speed or a rate. If the car travels at a rate of 60 miles per hour, okay, the car's speed, when will the car be ahead of the motorcycle? So this is my question. And to be ahead, that means that the car will have traveled more distance than the motorcycle. So sometimes I hate word problems. So I like to write out what it's asking in words first and then figure it out. So I noticed that they mentioned distance and rate. So I need to remember that distance equals rate times time. That is a relationship. Now, because they're asking for when will the car be ahead, that means the distance of the car being greater than the distance of the motorcycle. Well, I know that the distance the car travels depends on the rate and the time, or the speed and how long it's going at that speed. So in this case, the car has a speed of 60 miles per hour. So I'm going to write it as 60x. In 1 hour, it'll travel 60 miles. In 2 hours, it'll travel 120, and so on and so forth. Again, this is like a rate and a time, where x is the time, the number of hours. And I want to figure out where that will be greater than the motorcycle. Well, the motorcycle travels at a rate of 40 miles per hour, but we also know that it is 40 miles ahead. So again, this is the distance it usually travels based on the time. This is rate and time, which is a distance. And I'm going to add 40 because he's already 40 miles ahead. Now from here, you could totally graph one side, graph the other, and see where this is above this. Or if I were to solve algebraically, I would subtract 40x, divide both sides by 20. But you can't answer the question with just x is greater than 2. It says, when will the car be ahead of the motorcycle? Well, in this case, we would have to say after 2 hours. You want to make sure that you're answering the question. Okay, last example. Use graphing technology to approximate the solutions of the equations. So I'm going to go ahead and use Desmos, graphing calculator. Again, I'm just going to go on Desmos and I'm going to graph y equals negative x squared plus 8x minus 14. And I'm going to graph y equals absolute value of x minus 4. And I mean, I know that that one's going to look like this. I also know that this one is going to open down. So let's go ahead and see on Desmos what that gives us. So I already knew this one. And now I'm going to go ahead and graph this parabola. So I want to make sure that I'm sketching it because it's not a multiple choice. So I want to figure out that I'm sketching it. So it's going to go through 4, 2. And then it's going to have intersection points at 3, 1 and 5, 1. So back on my paper, I'm sketching it. But remember, the original question is asking you to solve, and the original only has x's. So while they meet at 3, 1, and 5, 1, my answer will be x equals, because I'm solving for x, and in this case, it would be x equals 3 and x equals 5. Okay? And you could see this being as one of the examples where maybe algebraically would be tougher. Because in order to get rid of absolute value, you have to split it. You get a positive, you get a negative. You have to factor or use quadratic formula. So this is where graphing actually becomes a little bit of the better way to solve. Another idea, I can ask you another what if. What if we had negative x squared plus 8x minus 14 equals absolute value of x minus 5? So I want you guys to go ahead and try this one on decimals right now and figure out what the x values would be, like what the solution would be rounded to 1 decimal place. Hopefully you got that the answer would be about 3.4. So x would be approximately 3.4 and x would be approximately 5.3. So that's it for these notes, okay? Try to use decimals wherever it asks for graphing technology or if it's something that you absolutely cannot see, okay? But tomorrow we're going to keep reviewing how to solve systems. In this case, these are not systems. These are just equations with one variable. We use a system to solve it, but our answer is only going to be the x value because the original question only has x's. Good luck.